Happy Monday. The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmayo@ybcc.edu and I'll respond as soon as I can. All right, so today, eventually, we're going to go on to section 10.2, part 2. But before we do that, I have several questions from 10.2 part 1. So we'll take a look at those. So this is from 10.2 part 1, which deals with the quadratic formula. All right, the first problem is number 7. And this one says, use the quadratic formula to solve the equation. Enter your answers as a comma-separated list. And the equation is as follows. 8x squared plus x minus 9 equals 0. This second degree or quadratic equation is already in standard form. So a is 8, b is an implied 1, c is -9. So the quadratic formula, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a becomes x equals -1 plus or minus the square root of 1 squared, which is 1. And then we've got -4 or -4 times 8, which is -32 times -9, which is a positive 288, all over 2 times 8, which is 16. Continuing to simplify, we get x equals -1 plus or minus the square root of 289 all over 16. Continuing, it turns out that 289, I believe, is a perfect square. The square root of 289 is 17. So we get x equals -1 plus 17 over 16, which is 16 over 16 or 1. X equals -1 minus 17 over 16, which is -18 over 16 or -9/8. So x equals 1 comma and -9/8. Any questions about that particular example before we go on? All right. We're going to take a look at number 8 in that same assignment. Again, it says, use the quadratic formula to solve the equation. Enter your answers as a comma-separated list. 72t squared minus 55t minus 7 equals 0. Now, again, this is in standard form for a second degree or quadratic equation. So we have a is 72, b is -55, and c is -7. So t equals -b plus or minus the square root of b squared minus 4ac all over 2a. So t equals, subtracting a negative is like adding a positive. So positive 55 plus or minus the square root of -55, the quantity squared, -55, quantity squared, oops, hang on here, is going to be a positive 3025. And then we've got -4 times 72 times -7, which is a positive 216, all over 2 times 72, which is 144. Going on, t equals 55 plus or minus the square root of, let's see, 2015 plus 3025 equals 5041 all over 144. Let's see if the square root of 5,041 is a perfect square. It is. It's 71 squared. So the square root would be 71 plus or minus all over 144. So t equals 55 plus 71 over 144, which is 126 over 144. Let's see, can we reduce that down further? Oh, 126 divided by 144 is 0.875, which I believe, hang on here, is we can reduce that. Let's see, what can we take out of that? Well, we can take a 6 out. If we take 126, let's do this, 126 divided by 6, hang on, 126 divided by 6, we get 21, and 144 divided by 6 is 24. Oh, 3 goes into both of those. So we end up with 7/8 as one of our answers. And then t equals 55 minus 71 over 144, which is, let's see here, 55 minus 71 is negative 16 over 144. And I believe we can divide the top and the bottom by 16, 144 divided by 16, and we get negative 1/9. So t equals 7/8, comma, negative 1/9. All right, that's number 8. Any questions on that before we go on? Same section, number 17 coming up. Excuse me, got a frog in my throat. Okay. Solve the equation, enter your answers as a comma-separated list. X times the quantity, x minus 24 equals 256. So this one is not in standard form. So we'll start out by distributing. We get x squared minus 24x equals 256. We'll subtract 256 from both sides of the equation. X squared minus 24x minus 256 equals 0. So now it's in standard form. A is 1, B is negative 24, C is negative 256. X equals negative B plus or minus the square root of B squared minus 4AC all over 2A. Again, subtracting a negative is like adding a positive. So x equals 24 plus or minus the square root of, let's see here, negative 24 times negative 24 is positive 576. And then we've got negative 4 times 1, which is still negative 4, times negative 256. Oops, didn't type that right. Negative 4 times 256, which is positive 1024 all over 2. X equals 24 plus or minus, let's see, 1024 plus 576 is 1600 all over 2. The square root of 1600 would be 40. So plus or minus 40 all over 2. X equals 24 plus 40 over 2, which is 64 over 2 or 32. X equals 24 minus 40 over 2, which is negative 16 over 2 or negative 8. So t equals 30, oh, excuse me, not t, we're at x. X equals 32, comma, or negative 8. All right, we've got 2 more to go here. Coming up next, number 19. Use the quadratic formula to solve the equation. 6x squared plus 0.7x equals 0.04. We could use the decimals, but I'm going to get rid of the decimals. So I'm going to multiply both sides of the equation by 100. On the left, that will give me 600x squared plus 70x equals 4. I'm going to subtract 4 from both sides of the equation. 600x squared plus 70x minus 4 equals 0. I see that all the terms are even, so I'm going to go through and divide everybody by 2 just to make things nicer. So I get 300x squared plus 35x minus 2 equals 0. So now I'm ready. I distributed, cleared the decimals, reduced it down. So A is 300, B is 35, and C is -2. Okay. And let's see here. We've got x equals -b plus or minus the square root of, oops, that's positive 35, of b squared minus 4ac all over 2a. X equals -35 plus or minus the square root of, let's see, 35 times 35 is 1,225. And then we've got -4 times 300 times -2, which is plus 2,400 all over 600. X equals -35 plus or minus the square root of 2,400 plus 1,225 is 3,625 all over 600. Okay, well, let's see if 3,625 is a perfect square. That would be nice if it was. So we'll raise that, take the square root, and it's not. Oh, well, that's unfortunate. Okay, so let's see here. 3,625, I can see that 25 goes into it. How many times? Let's see. So we take 3,625 divided by 25, and we get 145. Well, 5 goes into that. 145 divided by 5 is 29. So the only perfect square is the 25, so that equals that. And then we're going to get 5 square roots of 145. So that's going to go in the place of this, which is going to give us x equals -35 plus or minus 5 square roots of 145 all over 600. Okay. Now, I'm going to take that and recopy it on the next page. So I'm going to take this right here and put it on the next page. X equals -35 plus or minus the square root of 145 all over, let's see, oh, I left out a 5 there. Hang on. 5 square roots of 145 all over 600. I can see that the -35, the 5 square roots of 145, and the 600 are all divisible by 5. So I'm going to factor out a 5 on top, which is going to give me -7 plus or minus the square root of 145. And on the bottom, 5 times 120. I can now reduce out the 5s. So x equals -7 plus or minus the square root of 145 over 120. So your two solutions are x equals -7 plus the square root of 145 over 120, and x equals -7 minus the square root of 145 over 120. And it doesn't ask for decimal approximations. So there are the two solutions for that one. We good to go on? We've got one more, and then we'll go on to the new material. Okay, so this is number 23 coming up. Solve the equation, approximate the solutions to the nearest hundredth. Enter your answers as a comma-separated list. It says, let g of x equal 4.2x squared plus 0.2x, period. For what value or values of x is g of x equal to 3.35. So what we're going to do is that's going to go in the place of that. So our equation now becomes 3.35 equals 4.2x squared plus 0.7x. I'm going to subtract 3.35 from both sides. So I get 0 equals 4.2x squared plus 0.7x minus 3.35. I'm going to multiply both sides by 100 to clear the decimals. And I'm going to get 0 equals, let's see here, 420x squared plus 70x minus 335. I can divide all of these by a 5, so I'm going to do that. So divide by 5, divide by 5, divide by 5, divide by 5. And let's see here. 420 divided by 5 is 80, oops, wrong color there. 84x squared plus 70 divided by 5, 14x minus 335 divided by 5, 67. Okay, so A is 84, B is 14, C is negative 67. X equals negative B plus or minus the square root of B squared minus 4AC all over 2A, which is 84. X equals negative 14 plus or minus the square root of, I think 14 squared is 196. It is 196. And then we've got negative 4 times 84 times negative 67, which is plus 22,512, all over 2 times 84, which is 168. X equals negative 14 plus or minus the square root of, let's see, we've got 22,512 plus 196, which is 22,708 all over 168. Now, I could spend a great deal of time simplifying this, like I did on a previous one, but the directions, let me show you the directions here. It says approximate the solutions to the nearest hundredths. Okay, so that tells me it's not going to come out nice. So we're going to go straight to the calculator. First, we're going to put in x equals negative 14 plus the square root of 22,708 divided by 168. And we'll do that. Let's see here. Left-hand parentheses, negative 14 plus the square root of 22,708. Close up the parentheses with a right parentheses. Close up the entire numerator with a right parentheses, divided by 168. And I get 0.8136, which rounded to the nearest hundredth would be 0.81. Okay. And then I've got x is negative 14 minus the square root of 22,708 over 168. And let's see here. That is negative 0.980. So that to the nearest hundredth would be negative 0.98. And that takes care of the request for today. So with that, we're going to go on to part 2, which is going to be using the quadratic formula in some application problems. So this is what, 10.2 part 2. Okay. All right. Draw a picture here. Let's see here. And this is Nordstrom. And this is Best Buy. And this is Main Street. And First Avenue. All right. And then we need some crosswalks. Okay, it says refer to the illustration below, which is the one that I've drawn here. At least I think I switched back to the right whiteboard screen. Yeah, okay. Refer to the illustration below. Instead of using the Main Street and First Avenue crosswalks, which would be these, to get from Nordstrom to Best Buy, a shopper uses the diagonal crosswalk, so this one, to walk 97 feet directly from one corner to the other. So we've got this right triangle, okay? And the diagonal crosswalk is 97 feet long, okay? This is a right angle. If the length of the Main Street crosswalk, that's this one, is 7 feet longer than the First Avenue crosswalk, so Main Street is 7 feet longer than First Avenue crosswalk, this would be x, and this would be x plus 7, okay? How much walking does the shopper save by using the diagonal crosswalk? So what we need to do is we need to figure out this distance plus that distance, and then subtract that distance to find out how much the shopper saves. All right, before I go any further, do you have any questions about the setup, the triangle, where I got the numbers of the variables? All right, so what I'm going to do is I'm going to take this triangle and recopy it on the next page and kind of start over with working the problem. So this is 97 feet. This is x plus 7, and that's x, okay? All right, we dealt with right triangles earlier this quarter, so we're going to use the Pythagorean Theorem to find out the length and to find out what x is and then go from there. So the Pythagorean Theorem says a squared plus b squared equals c squared. C is always the hypotenuse. So C is going to be that, and A and B are going to be those, okay? So A squared would be x plus 7 squared. B squared would be x squared, and C squared would be 97 squared. Again, any questions there? All right. X plus 7, the quantity squared, is x plus 7 times x plus 7, which is x squared plus 7x plus 7x plus 49, which is x squared plus 14x plus 49, and then plus x squared equals 97 squared. 97 squared is 9,409. Okay. Combining like terms on the left, I get 2x squared plus 14x plus 49 equals 9,409. I'm going to subtract 9,409 from both sides. So I've got 2x squared plus 14x. And then, let's see here, 49 minus 9,409 is minus 9,360 equals 0. All right, those numbers are fairly large, but I see that they're all even. So I'm going to divide everybody by 2 just to make them a little bit smaller. So I get x squared plus 7x minus, let's see, 9,360 divided by 2, it's minus 4,680 equals 0. So now I have the equation I'm going to use. I'm going to take this and copy it on the next page. Let's see here. All right, so we've got x squared plus 7x minus 4,680 equals 0. A equals 1, B equals 7, C equals negative 46, 680. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. X equals negative 7 plus or minus the square root of 7 squared, which is 49. And then we've got negative 4 times 1. Negative 4 times 1 times negative 4,680. So that's plus 18,720 all over 2. X equals negative 7 plus or minus the square root of 18,720 plus 49, which is 18,769 all over 2. X equals negative 7 plus or minus. Let's see what the square root of 18,769 is. Whoa, it's exactly 137. Sometimes numbers come out nice. So x equals negative 7 plus 137 over 2, which is 130 over 2, or 65. X equals negative 7 minus 137 over 2, which is negative 144 over 2, which is negative 72. So x is 65 and x is negative 72. Now, here's the thing. What are we trying to determine? We're trying to determine some distances, and a distance can't be negative. So x equals 65 is the only correct solution that applies to the problem. So we go back here. This is 65 feet. This is 65 plus 7, which is 72 feet. 72 plus 65 is 137. So that's the total of going over these two. Minus the 97 is 40 feet. So you save 40 feet by taking the diagonal. Long problem, I know. Big numbers. Good thing we've got calculators to use on those. Any questions on that example before we go on? Okay. Let's take a look at another example. This says right triangles. So we've got a right triangle again. The hypotenuse of the right triangle is 2.5 units long. The longer leg is 1.7 units longer than the shorter leg. Well, the way I've got it drawn, this is the shorter leg. The longer leg would be 1.7 units longer than the shorter leg. Find the lengths of the two triangles. So basically, this is the same problem, just different numbers. in that they want us to find x so we can get the two sides, the two legs, okay? So again, a squared plus b squared equals c squared, and c is the hypotenuse, a and b are the two legs, or the two sides. So we've got x squared plus x plus 1.7 squared equals 2.5 squared. So x squared plus x plus 1.7 times x plus 1.7, whoops, equals, let's see what 2.5 squared is. I believe it's 6.25. 2.5 times 2.5 is 6.25. So we've got x squared plus x squared plus 1.7x plus 1.7x plus, I think 1.7 squared is 2.89, and it is 2.89 equals 6.25. Combining like terms, those go together and those go together. We've got 2x squared plus 3.4x plus 2.89 equals 6.25. We're going to subtract 6.25 from both sides. So 2x squared plus 3.4x, and then we've got 2.89 minus 6.25. That's is going to be minus 3.36 equals 0. Once again, I'm going to multiply both sides by 100 to get rid of the decimals. So I'm going to get 200x squared plus, oops, there's a decimal point there, plus 340x minus 336 equals 0, okay? I see that I can take not only a 2, but I can take a 4 out of each one of those. So divide by 4, divide by 4, divide by 4, divide by 4. 50x squared plus, okay, 340 divided by 4 is 85x minus 336 divided by 4, 84 equals 0. Okay. I'm running out of room, so I'm going to take that and put it on the next page. Are we good to go, or do I need to wait?
I'm good.
All right. 50x squared plus 85x. 50x squared plus 85x minus 84 equals 0. So A is 50. B is 85, C is negative 84, X equals negative B plus or minus the square root of B squared minus 4AC all over 2A. X equals negative 85 plus or minus, let's see here, oops, 85 times 85 is 7225, and then we've got negative 4 times 50 times negative 84, and that's plus 16,800 all over 2 times 50, which is 100. X equals negative 85 plus or minus the square root of 16,800 plus 7225 is 24,025 over 100. And let's see if that's a perfect square. Raise that to the power. Ah, yes, nice, 155 over 100. So even those huge, nasty numbers, we're getting some nice answers. So X is negative 85 plus 155 over 100. And let's see here. Negative 85 plus 155 is 70 divided by 100 would be 0.7. Negative 85 minus 155 over 100. Negative 85 minus 155 divided by 100 is negative 2.4. Well, as with the last problem, we're looking for lengths or distances, so they can't be negative. So x is 0.7. This would be 0.7. This would be 0.7 plus 1.7, which is 2.4 units. So back to the question where it said, find the length of the legs, it would be 0.7 units and 2.4 units. And there you have it. Okay. Let's take a look at this problem. It says picture framing. The matting around a picture has a uniform width. How wide is the matting if its area equals the area of the picture? Round to the nearest hundredth of an inch. So already we know this one's not going to come out nice. Nicely. Okay, so we've got this picture frame. And inside of it is a picture. That makes sense. And let's see, we've got a lake. And there's some trees. And there's a sailboat out on the lake. I know, I'm not an artist. Okay. So we've got the picture frame, this mat that goes around the picture, and then there's the picture itself. We are told trying to find my red pen again. We're told that from here to here is 5 inches. And from here to here is 4 inches. So we have the dimensions of the picture itself, not counting the mat frame around the edges. So the area of the picture is 4 times 5 equals 20 square inches. Okay, everybody all right with that? Now, it says, how wide is the matting if its area equals the area of the picture? So the picture is 20 square inches. The area of the matting is also 20 square inches. So the total area equals 40 square inches. So the whole thing equals 40 square inches. Okay? Again, any questions? Now, the matting is a uniform width all the way around. So let's call this distance right here x, which means this distance right here is also x as well as the others. So if this distance right here is x, then from, well, let's do it down at the bottom. Wouldn't this be x plus 5 plus x, or 2x plus 5 inches? I guess I don't need to put the, yeah. Yeah, you okay with that? Again, I could draw it up here. We've got an x and an x. So 2x plus 5. Everybody okay with that? All right. This distance would be x plus 4 inches. So 2x plus 4 inches. So basically what we've got is we've got a rectangle with an area of 40 square inches, and it's 2x plus 4 inches by 2x plus 5 inches. So using the fact that area equals length times width, we've got 40 equals 2x plus 4 times 2x plus 5. Are you with me?
Yes.
Okay, I'm going to copy that on the next page. So 40 equals 2x plus 4 times 2x plus 5. So 40 equals 4x squared plus 10x plus 8x plus 20. 40 equals 4x squared plus 18x plus 20. Subtract 40 from both sides. 0 equals 4x squared plus 18x minus 20. Everybody's even, so we'll divide everybody by 2. 0 equals 2x squared plus 9x minus 10. So we got our equation. We've got it reduced down. A is 2, B is 9, C is negative 10. X equals negative B plus or minus the square root of B squared minus 4AC all over 2A. X equals negative 9 plus or minus the square root of 81. Minus 4 times 2 is negative 8 times negative 10 is positive 80. All over 2 times 2 is 4. X equals negative 9 plus or minus the square root of 161 all over 4. Now, let me remind you, they said round it to the nearest hundredth of an inch. So that tells me things aren't going to come out nicely. 161 is not a perfect square. So I'm just going to go straight to the calculator. And the top one, so left-hand parentheses, negative 9 plus the square root of 161, close it up, close up the whole thing with another right parentheses divided by 4. And I get, let's see, where are we here? 0.922, which would be 0.92, and that's inches. So there's the first answer. And then the second one is negative 5.422, which is going to be negative 5.4 inches. Again, we're looking at a length or a distance, so it can't be negative. So round to the nearest hundredth of an inch, it would be 0.92 inches. So almost an inch wide all the way around. All righty. Let's see here. We got time for one more. We good to go on?
Yes.
This says IMAX screens. The largest permanent movie screen, at least at the time of this book being written, is in the Panasonic IMAX Theater at Darling Harbour, Sydney, Australia. The rectangular screen has an area of 11,349 square feet. Find the dimensions of the screen if it is 20 feet longer than it is wide. So we'll call the width X and the length will be X plus 20. So using area equals length times width, we get 11,349 equals X plus 20 times X. And here we go. 11,349 equals X squared plus 20X subtract 11,349 from both sides. 0 equals x squared plus 20x minus 11,349. So here we are in standard form. The numbers in these problems are certainly large, aren't they? Okay, so we've got, let's see, A is 1, B is 20, C is negative 11,349. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. X equals negative 20 plus or minus the square root of 20 times 20 is 400. Then we've got, see, negative 4 times 1 is still negative 4 times negative 11,349. And that's plus 45,396 all over 2. X equals negative 20 plus or minus, let's see, 45,396 plus 400 is 45,796 all over 2. Now, it didn't say round to the nearest hundredth. So that tells me that 45,796 hopefully will be a perfect square. Let's see. 45,796. 214. Excellent. All over 2. X equals negative 20 plus 214 all over 2. So you've got negative 20 plus 214, which is 194 divided by 2 is 97 feet. And then negative 20 minus 214 over 2. Negative 20 minus 214 is negative 234 divided by 2 is negative 117. And hopefully by now you're going, it can't be that because it can't be a negative distance. And they want to know the dimensions. So the width is 97 feet. The length is 97 plus 20, which would be 117 feet. So here's the width and the length. And there you have it. All righty. So for tomorrow, section 10.2, part 2, the story problems. Have a great rest of the day. I'll be back at 1:15 to 2:15 if you have any questions. And other than that, I'm going to go ahead and stop the recording.